Good morning. Today we are going to cover section 10.3, further identities. So take the time to copy down your title and your essential question. How do you rewrite trigonometric expressions that contain functions of multiple angles? We are going to cover the double angle formulas. So go and place your cutout, copy example number 1, and we'll start once you are ready. Go and pause it. Now, this is the last set of identities that we're going to cover. Your book also has other identities such as the half angle identities that we are not going to get to, but that'll be part of section 10.3. For purposes, we're just going to cover the double angle formulas, which means the sine of twice the angle, double the u, will be equal to 2 sine and cosine of u. We also have the tangent of 2u, the double angle for tangent. And notice that for the cosine of double the angle, we have 3 different ones. Now, your book also, once again, has the development of those formulas. So if you want to be able to see where the formulas come from. But for our purposes, we're just going to use them. And the use of them will be very similar to section 10.2. So let's go through example number 1. Given that the cosine of an angle is -3/5, they tell you that the sine of the same angle is less than 0. We need to find the sine of 2 theta, cosine of 2 theta, and the tangent of 2 theta. So let's go start with the sine of 2 theta. Now, if you notice, for the sine of 2 theta, we only have one equation that we can use. We are forced to use 2 sine of theta, cosine of theta. And we are able to substitute the cosine of theta. We know that is -3/5. So therefore, we can substitute -3/5. We have a 2. The only thing that we need to be able to find the sine of the same angle. So therefore, we are going to place an x and y axis for angle theta. I'll place an x and y axis. I need to determine where is my angle located. We'll determine that the cosine is negative, so it has to be on the second or third quadrant. And we know that our sine is less than 0, so it has to be on the second or the third or fourth. So therefore, it has to be on the third quadrant. So I'm just going to make a generic triangle. And the cosine is -3/5. So it's adjacent over hypotenuse. You now need to be able to find my missing side. And we know that is a 3, 4, 5 right triangle. So therefore, there should be 4, but not +4, but -4 because it's going down. So therefore, the sine will be your opposite over hypotenuse, which is -4/5. And I can simplify this. That gives me 2. Well, let's just multiply out. That gives me 12 times 2 is 24. So it'll be +24/25. Or just 24/25. And that is the sine of 2 theta. Now the cosine of 2 theta. For the cosine, we have 3 different identities or formulas that we can use. And you get to decide which one do you want to use. The first one, second one, or third. Well, because they give us cosine, just in case there's an error in the process that we did, we can use the second equation. So that will be 2 the cosine of theta is negative 3 over 5 squared minus 1. And now we just need to be able to simplify it. So simplify, see what you get, and then we can compare our answers. Going positive. So therefore, that gives me 2 times 9 over 25 minus 1. That gives me 18 over 25 minus 1. I'm going to make this over 25, so it gives me 18 25ths minus 25 over 25. Therefore, it gives me negative 7 over 25. So the cosine of 2 theta will be negative 7 over 25. And the last thing that I need, let's see, we found sine, we found cosine, sine of 2 theta, we have cosine of 2 theta, so now we just need to be able to find tangent of 2 theta. Now to find tangent of 2 theta, we can go through the formula that's given to us, but because we have sine of 2 theta and cosine of 2 theta, I can rewrite tangent of 2 theta as sine of 2 theta over cosine of 2 theta. And therefore, we know the sine of 2 theta is 24 over 25. We know that the cosine of 2 theta is negative 7 over 25. So therefore, the tangent of 2 theta, I can change my division to multiplication and multiply them across, or I can just multiply the top by 25 and the denominator by 25. And that cancels, so it gives me negative 24 over 7. Now, many times they might ask you where the angle is located. So see if you can determine where's sine of 2, or not sine of 2 theta, but just where's 2 theta located. 2 theta is located in which quadrant? Well, let's think about this. Let's see. I'm just going to make a small x and y axis. Sine of 2 theta is positive. That means that it has to be on the first and second quadrant. Cosine of 2 theta is negative. So it means it has to be on the left. And therefore, they both have quadrant number 2 in common. So it's in quadrant number 2. And notice that your tangent, it's also negative on quadrant number 2. So therefore, it does match. Example number 2. Go ahead and copy it down, pause it, and we'll start once you are ready. So we need to find the sine, the cosine, and the tangent. And it's telling us that the cosine of 2 theta is equal to 4 over 5. And it's telling us that the cosine of 2 theta, or that, no, theta is between 90 and 180. So we don't know where 2 theta is located, but we know the angle itself is on the second quadrant. So let's go and figure out how can we find sine. Now, because they're giving you cosine of 2 theta, we can use one of the equations or the formulas that are given to us, but we need to be able to decide which one to use, the first one, the second one, or the third. Well, because let's go and find sine first. If we're going to find the sine of theta first, I want something that's going to have sine of theta and cosine of 2 theta. So we're going to use this one here. So to find sine of theta, I'm going to use the third equation, the third formula, which is 2. What is the formula? Is the cosine of 2 theta. So therefore, I'm going to use the cosine of 2 theta is equal to 1 minus 2 sine square of theta. So therefore, I know the value of cosine of 2 theta to be 4 over 5. And now, because I only have the sine, now I can solve for sine. So go through the process, solve for sine, and see what you get. And then we can compare our answers. You got it? I'm going to pause it, otherwise. Move the 1 to the left, we can say negative 1. I need to have the same denominator. So I'm going to make 5 over 5. So therefore, that gives me negative 1 over 5 equals negative 2 sine of square of theta. I'm going to divide by negative 1/2, or I'm going to multiply by, I'm going to divide by negative 2, I'm going to multiply by negative 1/2. That gives me positive 1 over 10. That cancels. So sine of square of theta. I'm going to take the square root on both sides. So therefore, I end up with 1 over the square root of 10. And now I no longer have a square. The square root and the square cancels. I'm going to rationalize it. I'm going to multiply by the square root of 10. So that gives me square of 10 over 10 equal to the sine of theta. But I have an error. Can you spot my error? What is my mistake? Correct. In this case, I should have a plus or minus. So my square root and my square cancels. But every time we square root on both sides, we know we need a plus or minus. So I need to decide whether my answer is going to be positive or negative. They tell me that the angle is located on the second quadrant, right? So therefore, my angle theta, not 2 theta, but my angle theta is on quadrant number 2. So is my sign positive or negative on the second quadrant? Correct. My sign is positive. So we found the sine of theta. Now we need to be able to find the cosine of theta. Once again, they have cosine of 2 theta, so I have to use any of those 3 equations. Now, to find the cosine, I can use this equation, and because I already know the sine of theta to be square root of theta over 10, I can also use this equation here. I'm going to use this formula instead. I'm going to use the second one, so I can go through the same process. We have the cosine of 2 theta equals 2 cosine square of theta minus 1. And now, I'm going to replace the cosine of 2 theta with a value that we know, which is 4 over 5. So go through the process, solve for cosine, and see what you get. Go and pause it. So in this case, I'll move my 1 to the left. It's a positive one. I'm going to combine, I'm going to add both fractions. So it gives me 5 over 5, gives me 9 over 5. I can divide by 2, but because this is a fraction, I'll multiply by 1/2 instead. Saves me a step. So therefore, that's 9 over 10 equals cosine, the 2 cancels, cosine square of theta. I'm going to take the square root on both sides. The square of 9 is 3. The square of 10 is the square of 10. But let me not forget that's plus or minus. I'm going to rationalize it. Multiply by the square of 10, so it gives me 3 square of 10 over 10. And once again, my square root, why is my square root still there, right? That one should be gone, because that square root and the square cancels. So therefore, I need to decide whether that's going to be positive or negative. My angle of theta is on the second quadrant, so therefore my cosine is negative. So not plus, but only negative. And last, I need to go to find my tangent of theta. So to be able to find tangent, I can go and use my other equation, but notice if I find this tangent, I need to know the tangent of 2 theta. And I only know the cosine of 2 theta. But we know the tangent of theta equals sine of theta over cosine of theta. And we already know that the sine of theta is the square root of 10 over 10. And I know the cosine of theta is negative 3 square root of 10 over 10. Once again, I can take the reciprocal, or I can just multiply by 10. I can multiply by the reciprocal, I just multiply by 10, that cancels. So therefore, I end up with the square root of 10 over negative 3 square root of 10. My 10 square root of 10 cancels. So therefore, I have the tangent of theta to be negative 1/3. So one of the challenges is just about to decide what formulas to use when you are looking for sine. You just want the one with the sine. If you're looking for cosine, you want the one with the cosine only. There will be times that you can use the first formula as well, but that's if they give you one or the other. And we also have tangent. Example number 3. So some of our uses is just to be able to simplify expressions. We want to be able to be comfortable simplifying expressions such as this. And you'll seem familiar from the notes from 10.2. Go ahead and copy it down, pause it, and then we'll start once you are ready. So I need to be able to simplify the following expression. Once the first time that you see it is like, okay, what am I supposed to do here? But if you go back to the formula that we have, cosine squared minus sine squared, you start to identify that as cosine of 2u. Well, in this case, what is the value of u? U will be 7x. So therefore, that is equal to the cosine of 2u, where u is 7x. So therefore, that is the cosine of 14x. Those two expressions are equivalent. And let me not forget, not that right. How about letter B? What should I do with letter B? Which one should I use? We have 1, 2, 3, 4, 5 choices. So notice that in this case, this one seems to be the closest, right? But what are we missing? We're missing the 2. So this is what we're going to do. We're going to get creative and say, we have the sine of 15 degrees and the cosine of 15 degrees. I need 2. So can I just add 2? No, correct. I cannot just multiply by 2. I can multiply by 1, so therefore I can just multiply by 1/2 times 2. That is 1. And do you agree that those two expressions are equivalent? And therefore, I can substitute. My value of u will be 15. So therefore, that'll be 1/2. And this section is equal to the sine of 2u, where the value of u is 15 degrees. So therefore, 2 times 15 is 30. So we have 1/2 the sine of 30 degrees. And at this point in the class, you know that the sine of 30 is correct. It's 1/2. And 1/2 times 1/2 is 1/4. So knowing these properties is helpful to be able to simplify expressions. And you use this type of simplification of expressions once you get to calculus. but you want to get comfortable with it. Example number 4. Go and copy it down, and we'll start once you are ready. So write sine of 3x in terms of sine of x. So if we look at our formulas, we have the sine of 2u. We do not have the sine of 3x. So what should we do? So what we're going to do, we're going to rewrite the sine of 3x is going to be equal to the sine of 2x plus x. That is 3x, correct? So how's that going to help us? Well, we're going to go back to our sum formula that we covered on the last section for 10.2. And always remember sine, cosine, cosine, sine, cosine, cosine, sine, sine. And we are going to use our sine formula. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. But in this case, we need one with a plus. We're going to use this one here, where u will be 2x and v will be x. So see what you get, and then we can compare our answers. Got it? So therefore, that will give me sine of 2x cosine of x. That's a positive, so therefore this will be a positive. There will be cosine of 2x and u, sine of u, which is x. Now they only want us to be able to end up with sine of x. So now what we're going to use, we are going to replace the sine of x of 2x with so that's going to become 2 sine of u cosine of u, or not u, but in this case is x. Sine of 2x is equal to this part. I still have a cosine of x plus. Now I'm going to replace the cosine of 2x, and I have 3 choices. So I need to be able to decide which one to use. Should I use the first one, the second one, or the third? Now, because they want us to have sine of x, I'm just going to use the third one. So that'll be 1. I'll place in parentheses. And let me place it in red so we can see it. So it'll be 1 minus 2 sine square of x times the sine of x. And now we are going to simplify this expression and see where that takes us. Well, we know that that's cosine square, so therefore I have 2 sine of x multiplied by the cosine square of x. Correct? Cosine times cosine will give us cosine square of x. I'm going to distribute this out. So I have plus 1. That gives me minus 2 sine cube of x. And I need to be able to just end up with sines. They don't want any cosines in here. So I need to be able to find a way to replace the cosine square of x. And we know of Pythagorean identities, we know that sine square plus cosine square is equal to 1. So therefore, sine square of x plus cosine square of x equal to 1. So if I move my sine to square to the right, it becomes a negative. So therefore, I'm going to replace the cosine square of x with 1 minus sine square of x. Remember that they only want to have sine of x. So this seems a little Like, okay, what are we doing this for? These are the skills that you need in order to be able to do well in calculus, because you need to be able to manipulate expressions. Right? Plus 1 minus, well, and I missed a sine of x, right? This should be a sine of, do you guys see that? It's 1, so that gives me just sine of x, not 1. Minus 2 sine cube of x. And I'm just going to simplify it. So it gives me 2 sine of x minus 2 sine cube of x plus sine of x minus 2 sine cube of x. Let's combine like terms. So that expression is equal to 3 sine of x minus 4 sine cube of x is the same as the sine of 3x. Example number 5. Verify the following identity. So verify identities again. So I need to be able to prove that this expression is equal to this expression here. So I need to decide, do I start with the left or with the right? And notice that we have our double identities. So let me start to simplify this part. Sine of 2x. How many equations do we have for that? We have only one. Now for cosine of 2x, if you want to start with the right, the challenge is that we have 3 different formulas that we can use, and we don't know which one is going to drive us to the correct path. So therefore, I'm going to start with this one here. I'm going to rewrite it as 2 sine of x cosine of x. And my cotangent, I'm going to rewrite my cotangent as sine and cosine, or in this case will be cosine of x over sine of x. And let me simplify this and see where I get to, and then that will drive me to where I need to go. My sine of x are going to cancel out, and I just end up with 2 cosine square of x. So now, not sure where to go on the left, but I still need to simplify the right hand side with cosine of 2x, and now I can make a more informed decision. So I need to be able to decide which one should I use. This is where I need to get to. Cosine of 2x, should I use the first one, the second one, or the third one? So yeah, we can see that we can use the second one, right? So it'll be 1 plus 2 cosine square of x minus 1. And now we can see our path forward and our end game. That cancels. So therefore, so it's much easier than what it seems. The challenge is to be able to determine which of those 3 equations to use. And that's why I start on the other side, where I only have one option for the substitution, which makes the process much easier. And the last example for today, let's go and continue verifying expressions. Go and copy it down, and we'll start once you are ready. So let's see, we have cosine of 2 theta, once again. We also have sine of 2 theta. Well, for sine, we only have one option, correct? So I can start getting that one ready. So you know, for sine of 2 theta, and of course I can always change it to cotangent of 2 theta, but that's not going to drive us anywhere. So I know I can rewrite this as 2 sine of theta cosine of theta. I just don't know which one to use for cosine of 2 theta. And I don't want to guess, because I can start working on this side first. And probably that will take me to where I need to go. Cotangent, I can rewrite it as cosine of theta over sine of theta. Tangent will be sine of theta over cosine of theta. And now we know that whenever we have two fractions, we should add them. So therefore, I'm going to multiply the left-hand side by cosine and the right-hand side by sine. So therefore, my denominators will be the same. Cosine of theta, sine of theta, and I have cosine square of theta minus sine square of theta. So therefore now, it's okay, I have sine and cosine, I have that equal. I don't have my 2. But now I can see which one should I substitute cosine of 2 theta. Correct. Now we know that we have to use this one here. So it'll be 2 times cosine square of theta minus sine square of theta. And now we can see that the 2 cancels out. And I'm just going to rewrite my denominators to be cosine square of theta minus sine square of theta over cosine of theta sine of theta. So we match them and we prove that the identity was true. But remember that once you get to the point that you need to choose, you probably need to work with the other side or the rest of the identity to be able to decide. So this concludes the lesson for today. Have a great day, and I'll see you next time.